And now we turn our attention to another major central tendency, okay? That's another measure of location. That is the mode. What is the mode? The mode of a set of discrete varied value is the variable whose value occur most. That is simply the highest occurring frequency in the distribution. That's what the mode is. The variable whose value occur most in the given distribution. Now, the mode of a particular distribution can either be unimodal or bimodal, or it can be a uniform distribution. When we say that a distribution is unimodal, that is when it has only one mode. It is bimodal if it has two modes. It is uniform distribution if all the varied values in the given distribution occur the same number of times. We want to start first by looking at the mode of ungrouped data, and then we will now turn our attention to the mode of grouped data. I want to state that mode of ungrouped data is quite fair, easy to handle, okay, because that is where the major definition of the highest occurring frequency directly applies to. When you now come to mode of grouped data, there are certain technicalities that are applied. Okay, the mode of ungrouped data. For ungrouped data, the mode is simply the most frequent item. It has been stated, the item that occurs the most in that distribution. We have two questions on the board here we're going to solve. Okay, we'll answer these questions to help us understand the mode of ungrouped data. Look at question number 1. Find the mode of the data 5, 2, 8, 5, 8, 9, 5, 8, 5. Now how do we get the mode? Quickly go to the distribution and then check the number that occurs the most. And can we do that in C? If you look at this, you notice that 5 seems to occur the most. Okay, let's count the number of 5s that we have in that distribution. This is 1, this is 2, this is 3, and this is 4. If you count any other varied value, you notice that none is up to 4 times. Only 5, okay, appeared 4 times. Therefore, the highest occurring frequency here is 5, and hence the mode of this distribution. This will take us to question number 2. Question number 2, what is the mode of the following set of data? And the data we have is 2, 8, 4, 4, 8, 7, 4, 8. What is the mode? Once again, we're going to look at this distribution and then check the number that occurs the most. But from what I'm saying there, 4 appeared how many times? 1, 2, and 3. Then if you check 8, you will notice that 8 also appeared 3 times. 1, 2, and what? 3. Therefore, this distribution is a bimodal distribution because it has two numbers that appeared equal number of times most. And that happens to be 4 and 8. Therefore, the mode of this distribution is 4 and 8. Telling us that this distribution is a bimodal distribution. Now, let us look at a case that are suppose maybe all this distribution here, there is no number that appears more than the other. They're just the same number of times, okay? Consider the distribution is a uniform distribution. In the next video, we are going to turn our attention now to modes of grouped data, where we are going to apply the concept of calculation, alright, using formula method as well as graphical method, which of course we've treated before, the graphical method, okay, where we estimate the mode from histogram. So our attention will be based on calculating mode from formula. We now want to look at how we can estimate the mode. How do we determine it? For grouped frequency distribution, no longer ungrouped frequency, okay? Now, there are two methods that we can use to determine the mode for grouped frequency distribution. One of the methods is by calculation, where you use the formula. Of course, you see the formula on the board here. And then the second is graphical method, where we make use of the histogram. You will recall that under statistical tools used for data analysis, we already have dealt with how to obtain the mode from histogram. Is that okay? So our focus here is going to be how to obtain the mode by calculation method. Is that okay? So, if you want to obtain the mode using the formula method, what do? The first thing is to identify the class that is known as the modal class from your table. Alright, so you go to your group frequency table, look at that table, identify the modal class. And what is the modal class? The modal class is simply that class in that table that has the highest frequency. So all you need to do is go to the frequency column, check. Alright, what is the highest number in that frequency column? That highest number, the horizontal row, alright, of that highest number in that frequency column is your modal class. Does that make sense? So once you're able to identify the modal class, the next thing you need to do is to apply equation 9. That's the formula for the mode. Now let us look at this equation, okay? Mode is equal to x subscript NO plus open brackets f subscript NO minus f subscript NO before. You notice that I read this NO negative 1 as before because this is not like minus 1. Take note. That is not what it means there. Divided by 2 times FNO minus FNO before minus FNO after. You notice how I read this NO plus 1, right? This is not like mathematical plus as if you are adding 1 to this NO, right? I'm going to interpret the meaning of this once I'm done reading out this formula. So, enclose this in bracket and multiply by what? C. Now, what does these terms represent in this equation? Let us look at them. X subscript NO. That is the lower class boundary of the modal class. Remember, you've identified the modal class already. Is that okay? Then FNO means the frequency of the modal class, which is that highest occurring frequency. F subscript NO before means the frequency of the pre-modal class. That is the frequency of the class before the modal class frequency. Just imagine that this is your table, alright? You have your table this way, and then you were able to identify this to be the modal class. For example, let's say this is the modal class, and this is, let's take this to be our frequency, for example. Okay, let's take this to be our frequency. And having identified this row as the modal class, it means that this is going to be the frequency of the modal class, FMO. Then this FMO before means the pre-modal frequency. That is the frequency before the modal class frequency, which happens to be this on top. So this is your FMO negative 1. Then your FMO plus 1 is the frequency after the modal class frequency, and we refer to it as the post-modal frequency. So that's going to be this one, FMO plus 1. So that's the meaning of those terms there. Our C is class width or class size. And of course, in order to get a class width, you can obtain it from either the class limit by doing upper class limit minus lower class limit, or you can obtain it from your class boundary by doing upper class boundary minus lower class boundary. Once you are able to obtain all these terms from the table, your problem is solved. Simply substitute them into this formula and then calculate. What you obtain is your mode. Take notes. The calculation method by formula gives accurate results compared to the graphical method. Of course, the reason is simple. In the graphical method, you would have to select a scale. After selecting the scale, you would have to trace points. Of course, errors due to parallax might make your result not to be absolutely correct as it should be. In the next video, we are going to take question and see how we apply this formula. Now we have this question on the board. Let's look at it together and then solve using the scores of the sample of 45 randomly selected students in a statistics examination in table 2A. Calculate the modal score of the students. Alright, so this question is based on table 2A. We'll recall that we already established this table 2A previously, okay? So for this problem, to solve it, I just extracted the columns we need to calculate the mode. And what we need to do, we have to recall the mode formula, okay? The mode formula is equal to XMO plus open brackets FMO minus FMO minus 1, that is the pre-modal class frequency, divided by 2 times the frequency of the modal class minus the frequency of the pre-modal class minus the frequency of the post-modal class. So we're going to multiply all of these by what the class width C. Now we would go to this table and quickly identify our modal class. And what is the modal class? You would recall it was stated that it is that class with the highest frequency. So we would locate the frequency column and check what is the highest frequency there. Can you tell me? Alright, I agree with you. It is 10. Okay, so this is the highest occurring frequency. Therefore, this class gives us the what? The modal class. We can pick all our data from this class. Is that okay? Which is the modal class. Now let us go. SMO, which is the lower class boundary of the modal class. So I'll go to the class boundary. The lower class boundary of that modal class is 64.5. So we're going to write 64.5. Okay, then move on. The frequency of the modal class already we've obtained is 10. Then we'll get the frequency of the pre-modal class. Okay, frequency of the pre-modal class, that is the class before the modal class. Its frequency, look at it, is 8. Just the class above the modal class. That's 8. We're going to obtain the frequency of the post-modal class. Frequency of the post-modal class, the class just after the modal class. The frequency is 7. Now the class width, we can obtain the class width either from the class boundary by doing upper class boundary minus lower class boundary, or you obtain the class width from the class limit by doing upper class limit minus lower class limit, then you add 1. Is that okay? Take note of that, please. I didn't state it previously. I'm now saying if you're using class limits to obtain your class width, it is upper class limit minus lower class limit plus 1. Or you can go by counting straight from the lower class limit to the upper class limit. For example, from 50 to 54, we are counting 50 and 54 inclusive to be 50, 51, 52, 53, 54. Alright, I prefer using class boundary to obtain my class width so as to avoid any mistake. So we're going to go to the class boundary, do any upper class boundary minus the lower class boundary, okay? You can do any one of them, but let me just use that of the modal class. You still obtain the same result anyway. So it's going to be 69.5 minus 64.5. 69.5 minus 64.5. It's giving me 5. So our C is equal to 5. We are as good as done. We cannot substitute into the mode formula. So that our mode will now be equal to the XMO, that is lower class boundary of the modal class, is 64.5 plus, open bracket, frequency of the modal class is 10, going to minus frequency of the pre-modal class, which is 8, divided by 2 times frequency of the modal class, which is 10, minus frequency of the pre-modal class, which is 8, minus frequency of the post-modal class, which is 7. We're going to multiply everything by the class width, which is 5. Alright? So if you work out this, how do you go about it? Have 64.5. Okay? Be done with the bracket first. Finish up everything in the bracket first. If you come to the bracket, how do you go about it? The numerator is 10 minus 8, which is going to give us 2 all over. Denominator, of course, you know the rule of BODMAS, you need to be done with multiplication first. 2 times 10 is 20. 20 minus 8 is what? 12, right? Then 12 minus 7 is going to give us 5. So this is over 5 times 5. Do you know that mathematically? Remember, you must follow the rule of BODMAS. So this plus 64.5 is the last thing you need to do. Coming over here, this 5 will cancel this 5 if you seek to open up the bracket. So you'll be left with 64.5 plus 2. So 64.5 plus 2 will give us the mode by calculation for this problem to be equal to 66.5. Of course, it's going to be in percentage because the scores of the students were given in percentage. Of course, you can see how easy it is to solve this problem, okay? There is no difficulty in it. You want to obtain mode from calculation. First of all, simply identify the model class from the table. Is that okay? Then from the model class, you can get all of these parameters. Once you get all of this data, substitute and simplify, you get a result. This is GMAT 41. You are welcome to our statistics class. In this video, we now direct our attention to another form of measures of location, which is the median. The median is one of the most common measures of location because of its occurrence in other measures. Like measures of position, we encounter median there. When we talk about measures of position, we refer to fractiles. That's where we encounter quartiles. We talk about deciles. We talk about percentiles. Each of these fractiles have their own median. So median indeed happens to be the most common form of measures of location. But we want to start first by getting to know what median is. Just hear the word median, middle, alright? Middle. From there you get the word median. Median is simply the central observation of a given distribution. Now when you're talking about ungrouped data in most cases, it is important for you to arrange the distribution either in ascending or in descending order. So that is what median is. The central observation of a given distribution. Now, we want to look at how we can obtain the median of a distribution because it can be obtained both for ungrouped data and for grouped data. So first, we're starting with the median of ungrouped data. The median of ungrouped data can be obtained in a case where the given observation is odd number. That is, if you count the number of items you have there and it gives you odd number. How do you obtain the median? Equation 9 can help us to quickly identify our median there. After arranging the distribution either in ascending or descending order to obtain the median position, simply obtain n plus 1 divided by what? 2. The n plus 1 item divided by 2, is that okay, gives us the median. This is position, take note. We are trying to say to locate the position of the median, you need to do this, where n is the number of observations. Now, for example, imagine you're given a distribution and you can't, and it happens that the number of distribution there is maybe 9. Alright, 9 items. What are you going to do? That 9 is odd. So you're going to do 9 plus 1, giving you 10 divided by what? 2. You get 5. So the number, the item in the 5th position of that distribution will now give you what? The median. That is for what? Ungrouped data. In the case where you have odd number of distribution. What if you are dealing with ungrouped data and then the number of observation happens to be what? Even. What do? Equation 10 will help us to obtain the median of such distribution. Here we need to get an average. What do we do now? Watch. You locate the item occupying the nth over 2 position counted from the left. Obtain the item, the number occupying the nth over 2 position counted from the what? Right. So those two numbers you obtain, add them together and divide by what? 2. You get your median directly. When we solve questions, we're going to see how we apply this equation 9 and 10. Note, there are certain distribution that is still ungrouped distribution, but then they come with frequency. In such case, this idea is also used to obtain our median. Only that the n is now replaced with what? Summation f. That is summation of frequencies. In the next video, we're going to take questions to see how we use this formula to obtain our median. We now have these 2 questions on the board, right? To obtain the median of the distributions shown there. So we're starting with question number 1. Let's say that what is the median of the distribution? So this is the distribution, you can say that. Now how do we solve that? For question number 1, okay? So remember, to get the median for ungrouped data, the first thing you need to do is to arrange either in increasing or decreasing order. I prefer arranging in increasing order. So coming over here, I will start. The least number is 1, so I'll have 1. After 1, the next is 2. Followed by 3. 3 appears 2 times in the distribution, so you're going to locate it. Then the next is 4. There is no 5. The next is 6. Then we'll have 7, 8, and what? 10. Good. This is the distribution arranged in increasing order. So the next thing we're going to do is to get the number of observation n and then find out whether it is even or odd. You can count that out here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 items there, and that 9 is what? Odd. Because it is odd, we can now obtain the median by using the formula median position. Median position is equal to n plus 1 over 2 item, right? The item located at this position is our what? Median number in this problem. So let us solve this and see. This will be equal to, our n is 9 plus 1, so we're going to divide it by 2. If you do that, 9 plus 1 is 10 divided by 2 is 5th. So the fifth item in this distribution is our what? Median. Therefore, the median of this distribution is equal to, we'll come here and then count and locate the number that will be same at the 5th position. So 1, 2, 3, 4, and 5. That is the number 4. So 4 is the median. Even if you count from the right hand side towards the left, it will still land you at this 4. 1, 2, 3, 4, and 5. So 5, the 5th position, the number there is what? 4. And that 4 is our what? Median. Now let's look at solution to number 2. Find the median of, look at the distribution here. So once again, we're going to arrange it in increasing order. So I will start, the least number here is 8. So I have 8, after that we have 12, after 12 we have 16, after 16 the next number is 20, after 20 we have 23, then the highest is what? 31. Once again, let us get the number of observation n to see if it is even or odd. If you count that, 1, 2, 3, 4, 5, 6. So there are 6 numbers here, and 6 is what? Even. Because 6 is even, we can now get our median position. Median position is equal to, remember, it's the nth over 2 item from left hand side. From left hand side plus the nth over 2 item from right hand side. Right hand side, then divided by what? 2. Now that is going to be equal to nth over 2. Our n is 6. So it's going to be 6 over 2 from left. The 6th item over 2 from left hand side plus nth over 2 again, the 6th item over 2 from right hand side. Once you locate those numbers, add them and divide by what? 2. So let us go on. 6 over 2 is the 3rd item. 3rd item from left hand side, plus 3rd item, 6 over 2 again, from right hand side. Right hand side. What we get there, we're going to add and divide by 2. So let's do that. 3rd item from left, 1, 2, 3. It landed us on 16. Plus 3rd item from right, 1, 2, 3. It landed us on 20. So we're going to divide this by 2. 16 plus this divided by 2 will give us 36 over 2. Therefore, the median is equal to 36 over 2 will give us what? That should be 18, right? So this is how we obtain our median using the equation 9 and 10 given earlier. In the previous videos, we solved questions where we had ungrouped data and then we had to obtain the median, alright? Because this does not have a frequency, it was fairly easy to obtain that. In this video, we now wish to determine the median of ungrouped distribution. But this time around, it comes with frequency. We'll have this question on the board. Find the median of the following data shown in the table below. This is the table. We have these marks and the corresponding frequencies. How do we solve this to obtain the median? Solution. The first thing we need to do is to create a cumulative frequency column for this distribution. Please get your pen, get your book, and then you write. Now you can see that I had to bring out the mark column, the frequency column. Of course, you need to sum the frequencies, you add up everything, and then we have the cumulative frequency column created. You know, you obtain cumulative frequency from frequency by adding up the frequencies. In our previous videos, we've already treated that. We urge you to check that up in our video collections, okay? So we want to see how we can now proceed to obtain the median mark The first thing we need to do is to identify summation f, the total frequency. Now the total frequency as given in this question is 41 from this table as we've seen. Okay, if you solve this by adding it up, you get 41. And then that 41, you observe that it is an odd number. Okay, very important. This summation f represents our n in cases where it does not have frequency. But here it has frequency, so we replace n with what? Summation f. Because this frequency summed together is an odd number, using our median position formula, median position is equal to, it's going to be summation f plus 1. Okay, the item occupying this position of summation f plus 1 divided by 2. So let us do that and see. That is going to be summation f is 41 plus 1 and then divided by 2. This will give us 42 over 2, which is 21. At this point, what do we do? Are you ready to write? Good, keep writing. Let's go. With this 21, we would go to the cumulative frequency column and locate 21. That's the first thing we do. But now let me ask you, look at this 21. If you come to this cumulative frequency column, do you have it there? I can't see any 21 there. Suppose there was 21 exactly there, fine. We could just trace that 21 down to the mark column and check the mark where it will land us on. And that mark will become our median mark. But there is no 21 exactly. So pick two cumulative frequencies where 21 will be found in between. And then 21 will be between 18 and 29. It will be between here, right? It will be between 18 and 29. What do? Pick the higher cumulative frequency. That is the next higher cumulative frequency. Between 18 and 29, 29 is greater than 21, right? So you pick this 29. It means that this 29 will represent our median position. So you trace from there to the mark. And that landed us to what? 22. Therefore, the median mark is equal to 22. And that's simply how we approach this problem. In this video, we have a question on the board. Okay, we have to find the median age of students shown in the table below. This is the table. So our aim is to determine the median age. Here, what will be the median age? Now, this distribution came with frequency as well too. So for us to solve this, we need to complete a cumulative frequency column for it, right? So I have the solution on the board here. I decide to bring out the table. Okay, this is the age column or frequency column, which of course we need to get the summation of the frequencies. And then the cumulative frequency column has been created and completed, alright? We've already explained how to obtain our cumulative frequency in previous videos. So let us move on to now get our median age. The first thing we need to do is to identify our summation f. From the frequency column, summation f is equal to what? 30. So 30, is it even number or odd number? What do you say? 30 is even, that's correct. So we get it right, even number, right? Now, when the number of distribution is even, because you know this summation f represents n, the number of distribution. We are using summation f now because we are dealing with a distribution that has what? Frequencies, okay? So, since this is an even number, you know that to obtain the median for even distribution, all you need to do is to solve for summation f over 2. Once you're able to locate the item summation f over 2, count from left to that item, count from right to it, and then pick the average, alright? So I'm going to write this, that median position is going to be equal to the average of summation f over 2 item from left and right. You know, that's how we actually get it. Count from left to get that item, count from right to get another item. There will be 2. So you find the average of the 2. In this case, we are dealing with tables, so we're going to count from top to bottom, bottom to top, and locate those 2 numbers whose average we are meant to get. Now, summation f here is equal to what? 30 is equal to 30. 30 divided by 2 will give us 15th item. 15th item from left and right. So we're going to locate this 15 in the cumulative frequency column now. So you get your pen and your book and follow along as we do that. We'll come to the cumulative frequency from top, going down, we locate if we see 15. And of course, we have 15 there, right? So this is exactly the 15th item. So we are going to get its age, which corresponds to 21. And you know, for the fact that this is even distribution, once you've located from top to bottom, which is the same as from left to right, the next item also is part of what? The median, which is the same as counting from left to the right, or from bottom to top. So if I am moving from bottom up now, it will correspond to this 24. So you trace it to the age. Because once I'm able to locate this, the next part of the median will be the next number. Or if I move from under up, the next will be what? This number. So you're going to locate the two ages, so that my median is now going to be equal to median age 21 plus 22. So I'm going to divide it by what? 2. 21 plus 22 will give us 43 over 2. 43 divided by 2 is 21.5 years. So this is the median age for this problem. Alright? Ungrouped data whose summation of frequency gave us what? An even number. In this video, we are still going to obtain the median of a given distribution with frequency. I kind of like this question a lot, in fact I love it, alright? I'm going to tell you why I like this question specifically. We're going to compare it with our previous question number 4 and see the reason why this is a special kind of question, okay? Let us read the question together and then I'll solve this. Are you ready? Determine the median of the income of some laborers shown in the table below. This is the table, this is the income, and then their corresponding frequencies. Now how do we solve this? Still similar to what we saw in the previous question, but just a little different, where you don't want to locate your position from the cumulative frequency column. Alright, you know that the first thing you need to do in solving is to create and complete your cumulative frequency column, right? So you could see that I brought down the income, look at them, okay? Then your frequencies, of course I have to find summation of the frequency. That is the frequency is 42 here if you add up these. Then this is the cumulative frequency column created and completed, as you can see. Of course, from our previous videos, we've explained how you obtain the cumulative frequency values from the frequency column. Of course, the less than cumulative frequency, because we have one called the more than cumulative. For all this calculation, we use the less than cumulative, where we add from top to bottom to get their cumulative frequencies. All right. Now, to proceed in obtaining the median income, the first thing we need to do is to identify our summation F. Summation F there, is 42, as you can see from the table. So you're going to find out whether it is even or odd. What do you have to say? The number 42, good, you're correct. It's an even number. Because it is an even number, then to locate our median position is going to be summation F over 2I10. Counted from left to right and from right to what? Left, to locate the median position. They're going to add up the two numbers and divide by what? 2. But of course, we are dealing with tables here, so we're talking about counting from top to bottom and from bottom to top. You locate the median position, the two numbers, add them and divide by what? 2. But of course, if you're locating it from the cumulative frequency column, we need to trace it to the income because the median is obtained from the income. So let us see that. So I'm going to write median position. Median position is going to be equal to summation of F over 2. I'm going to write a short form of this formula once again, alright? So summation of F over 2 I10 from left and from right. We'll be using left and right, okay? But take note that since we're dealing with table, is from top to bottom and bottom to top, okay? The concept of left and right is for problems where you don't have frequency. No frequency given, you talk about left and right, although they're still the same. Left to right, top to bottom. Right to left, bottom to top. Good, let us obtain summation F. The median position now is going to be equal to, summation F is 42, so we're going to divide it by 2, and if you do that, you'll get 21. So the 21st position, okay, the income occupying that position is now what we are going to add the two of them and divide by 2 to get the average, which is now our what? Median. But now what do we do with this 21st position? Because you know what we've done from the previous question, pick your pen and your book and then listen as I tell you what to do with this 21st position. So you're going to go to the cumulative frequency column and locate 21. Are you ready? 21, let's go to the cumulative frequency. If you look at this, there is no 21 in the cumulative frequency column. Is that not so? Because there is no 21, what do? We will locate the two cumulative frequencies where 21 will be found in between. And that will be between 18 and 29. So look at the cumulative frequency 21 will be found between 18 and 21. This is and 29. This is where we will locate our 21. In fact, let me write it, okay? 21 is between 18 and 29. So what do? You are going to pick the next higher cumulative frequency. And the next higher cumulative frequency is what? 29. Just greater than 21, as you see from the cumulative frequency column. Hence, it is the income of this 29 that we're going to use to obtain our what? Median. So I'm going to trace it this way. I'm going to trace it. Now, this is the point where I love this question a lot. You would recall that in the previous question number 4, when we did summation f divided by 2, it was 30 over 2, which was 15. We're actually dealing with age. We dealt with age in that case. Now that 15, we saw it exactly in the cumulative frequency column. Hence, what did I do? I told you in such a case where the number is exactly in the cumulative frequency column, all you need to do is trace that number to, of course, the age in that question number 4, and then pick the next cumulative again and trace it. Add both and divide by what? 2. That's what we did there. Because when we did summation f over 2, the number we got, which is the 15th position, appeared in the cumulative frequency column. In this case, the 21 did not appear there directly. And you know that because summation of f is an even number, you must add 2 middle numbers and divide by 2. Take their average to get the median. So what do we do here? Are we going to say, okay, pick the income of 18, pick the income of 21 and divide by 2? You don't do that. We don't say, okay, since you have selected 29 to be the next higher cumulative, pick the income of 29, pick the income of 37, and then add. You don't do that. Since 21 is not exactly there, and you have picked the next higher cumulative frequency, because that's the principle. What you're now going to do is to double that income and divide it by 2, which means you are saying that 21 appeared twice in the 29th cumulative frequency. So we are now going to say that median is equal to, come over here, 21 occur in that 29, so it will be 22 income plus, since the 21 is not exactly in that cumulative frequency, it means you're going to repeat this number, plus 22, then divided by what? 2. If you add 22 plus 22 and divide by 2, what will you get? 2. So the median income is 22 naira. You're going to get 22. 22 naira is the median income. So please, do not forget why I really love this question, okay? But let me tell you something. Suppose the 21 is exactly in this column. Let's assume that this 18 was 21. What you will do is pick this 20, then pick this 29. You add 20 plus 22, and then divide by what? 2. But once again, because the 21 is not exactly there, pick the next higher cumulative, trace it, double the value, and then divide by 2 to get to what? Median. In this video, we want to say how we can determine the median of grouped frequency distribution. You would recall previously that we treated how to get the median for ungrouped distribution. Now, for grouped data, it's important to know that the median is not as straightforward as it could be if you're talking about median of ungrouped distribution. To obtain the median for a grouped frequency distribution, one can go about it in 2 different ways and then arrive at almost the same result. Alright? One of the methods is by formula calculation method. The other method is graphically, where we obtain the median from the less than cumulative frequency curve, known as the Ogilvy curve. In this video, we are going to focus more on how to obtain median using the formula. And on the board here, we have the formula that is used in calculating median. Just similar to what we saw for mode. How to estimate mode by calculation. Now let's look at the formula here on the board. To get the median is equal to x subscript me, which is the lower class boundary of the median class, plus open bracket summation of all frequencies divided by what? 2, minus cumulative frequency of the pre-median class, that is the class before the median class, divided by the frequency of the median class. Close your bracket and multiply by the class width, C. Our C.F subscript ME minus 1, because I stated already, it means the cumulative frequency of the class before the median class, known as the pre-median class. For us to use this equation 11 to calculate the median, the first and most important thing we have to do is to determine the class known as the median class from our frequency table. If we are able to determine the median class, then we can be able to obtain the values of all these frequencies of the median class, cumulative frequency of the pre-median class, the lower class boundary of the median class. So take note of that. You must have to determine the class known as the median class from your group frequency table. Now, how do you obtain this median class? So it's important you go through this. Is that okay? The first thing you do in order to determine your median class is to obtain summation f all over 2 value. That is the total frequency divided by 2. Now once you obtain this total frequency divided by 2, the next thing you need to do is to go to the cumulative frequency column of your table and see if you can obtain this value of summation f over 2. If that value is there in the cumulative frequency column, then that row will become your median what? Class. But suppose I'm going to your cumulative frequency column, you check for the value of summation f over 2, and that value is not exactly there. Then take the next cumulative frequency value that is just greater than the value of summation f over 2. That would be your median class. Then you can pick out the necessary data, include into this equation 11, and solve for the median. In the next video, we're going to take questions and see how we apply this formula. In this video, we are going to attempt to obtain the median of the scores of some students that sat for statistics examination. We are going to use the formula method to obtain the median. Look at the question here on the board. Using the scores of the sample of 45 randomly selected students in a statistics examination, reference was made to table 2A. Calculate the median score of the students. Okay, so how do we solve this problem? You would recall that in the previous videos, we've already established this table 2A from a given problem. It's a group frequency distribution problem actually. And so we are asked to find the median score of these students. So what do we do? First of all, we have to bring out the required table, the column we need from table 2A. Remember, you're calculating the median. So you need the class boundary column, you need a frequency column, you need a cumulative frequency column, alright? Of course, the scores of the students, important as well too. These are the things you need because of the parameters that are seen in the median formula. So how do we go about that? First of all, let's recall the formula we need to obtain the median score. So I'll recall, we obtained already that median is equal to that is lower class boundary of the median class, right? So we're going to add it to open brackets, summation of the frequencies divided by what? 2 minus the cumulative frequency of the pre-median class, all divided by the frequency of the median class. We're going to multiply this term by the class width of the median class, supposedly. Good. How do we obtain these values for these parameters we have here in the formula? We have to go and determine the median class from this table first. So how do we get the median class? To obtain the median class, because we know that we need summation f over 2. And summation f, the frequencies added together is 45, divided by 2 is 22.5. Now, get your pen, get your book, and write what we're going to do from here now to get our what? median class. We've obtained 22.5 from summation f over 2. Look at this part of the formula, very, very important. Not just for calculating median, but for calculating fractiles, that is measures of positions, the quartiles, the deciles, the percentiles. Very, very important. We're going to encounter it again when we talk about those measures of position. Alright, with this 22.5 as the value of summation f over 2, now go to the cumulative frequency column. Are you there with me? So this is the cumulative frequency column. I'm going to check if I will get 22.5 there. So I'm going to ask you, did you say the 22.5 in the cumulative frequency column there? Did you? Alright, good. No, there is no 22.5. Because there is no 22.5, what do? You're going to pick the next cumulative frequency value that is just greater than 22.5. And of course, if you look at this, 22.5 will be between 16 and 26. Is that also? Now, if 22.5 is between 16 and 26, means that the next greater cumulative frequency of this problem is going to be what? 26. Therefore, we're going to pick this as the median class. So, let me roll out something like this. This is our median class. Hence, all calculations will be based on that class. Alright? So, we're going to obtain the values of all these parameters. It implies that XME, that is the lower class boundary of the median class, will be located here at 64.5. 64.5. Then we have the pre-median cumulative frequency. Right, now the cumulative frequency of the pre-median class is what? 16. That is the class just above the median class. 16. Of course, we need the frequency of the median class. Frequency of the median class, look at it, that's 10. Then we need the class width. How do we get the class width quickly? Upper class boundary minus lower class boundary. So we're going to do that here, 69.5. 69.5, I'm using that of the median class. Then minus 64.5. And that's going to give me 5. You can use any other class to obtain the class width, but preferably, let's just base our calculation on the median class. Having obtained these terms, I can now calculate the median. So my median score will now be equal to lower class boundary of the median class, 64.5, then plus summation of the frequency divided by 2. We already got it to be 45 over 2, which gave us 22.5. So I can just put the value there, 22.5, then minus the cumulative frequency of the pre-median class, which is 16, all divided by frequency of the median class, which is what? 10. We're going to multiply by the class width, 5. So the median, our median score will now be 64.5. We're going to add it to, let's be done with everything. We have a bracket here and multiply by 5. Are we ready? So let's switch out for our calculator and press 22.5 minus 16. It's giving me 6.5. So I'm going to divide that 6.5 by 10, 0.65. So this whole bracket is 0.65. Let's now multiply it by what? 5. That is 3.25 here. I'm going to add this to 3.25. In conclusion, the median score for this student in this statistical examination is equal to, if we add this 3.25 plus 64.5. So from here it's giving me 67.75%. So this is the median score of the student in this statistic examination.